In this video, we're differentiating the square root of x plus 1 over x cubed. And in our first step, I'm going to re-express that square root as a fractional power just because that makes it easier to work with the power rule. And I'm also going to express this 1 over x cubed in terms of a negative exponent. So inside this thing, I have x plus x to the negative 3. And then that's all raised to the 1/2 power. Remember, that's equivalent to taking a square root. So we have a function composition here where the inner function is x plus x to the negative 3. And then that whole thing is being raised to the 1/2 power. So we have to apply the chain rule. And we differentiate this thing with respect to its interior. And just applying the power rule, we get 1/2 out in front times that interior function to the negative 1/2. Now the chain rule says we have to tack on the derivative of the interior function. And that's going to be a 1 minus 3x to the negative 4. So then the main challenge of the problem is actually just cleaning up this final result. So we're going to write this thing as a single fraction, and we're also going to get rid of those negative exponents while we're working. So in our numerator, we have 1 minus 3 over x to the 4th. And then with that 1/2 out in front, that becomes a 2 in the denominator. And the other thing in our denominator, I'm going to turn it back into a square root here, is the square root of x plus 1 over x cubed. So now we're left with a complex fraction. In other words, a fraction that contains fractions in its numerator and denominator. And we have to figure out what to multiply by on the top and bottom to eliminate the complex fractions. Well, I have a 3 over x to the 4th in this numerator. So I could eliminate that denominator by multiplying by x to the 4th. And x to the 4th is more than enough to eliminate this x cubed inside the square root in the denominator. So we're going to multiply by x to the 4th over x to the 4th. And we distribute that into each of the terms in the numerator. That gives us x to the 4th minus 3. So that's looking good. And then the denominator is a little bit tricky. And what I'm going to do as my first approach to this is I'm going to take x squared. So I'm just splitting off an x squared. And I'm going to distribute that into the square root where it becomes an x to the 4th. That leaves me with an extra x squared out in front of that square root. So again, distributing an x squared into a square root, it becomes an x to the 4th in there. So I end up with an x to the 5th. And then in my second term, x to the 4th over x cubed is just x. And I think that's a fine way to leave the answer. Now, an alternative approach to the answer is that I could factor an x out of that square root, because I notice I have an x common to each of those terms inside the square root. And that becomes an x to the 1/2 factored out into this denominator. Well, combining that with the x squared gives us x to the 5/2, just because 2 plus 1/2 is 5/2. And then inside the square root, we'd be left with an x to the 4th plus 1. So I personally think that the first way I wrote this is the best because it doesn't include any fractional exponents. But I decided to include this second way as well because when I checked my answer with a computer algebra system, the computer decided to simplify it that way instead. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.